Today we're going to start actually doing some more calculations, things that you probably have heard before of, like the mean, median, and mode. So these are all called measures of central tendency. So central tendency just refers to the center of the data. So these are three different types of ways that we can look at centers. And each of them really has their pros and their cons. So let's go through the definitions and calculations for each one. So first, a measure of central tendency is a value that represents a typical or central entry of a data set. Three of the most common central tendencies are the mean, the median, and the mode. And there are others too, but these are the three we tend to use the most. Now, the mean, just so you know, is your typical average. So the mean of the data set, is just the average of the data set. To find it, we add up all the data points and then divide by the total or the sample size. So just like a regular average, you add up all the data points and divide by however many you have. So that definition doesn't change. We do use the word mean though instead, just to be really clear. Sometimes that word average could be used for median as well or mode, although it doesn't usually happen. But mean is just much clearer definition or vocab word. So we're going to use mean as much as we can. Now, for some notation here and some symbols, we do distinguish the symbols between a population mean and a sample mean. So when you talk about a population mean, we use the symbol mu, which is a Greek letter M. And when we talk about the sample mean, we use an X with a bar on top. So again, this is pronounced mu, and it's the Greek letter M. It's a lowercase letter. And here we often call this as X bar. So that is how we represent a sample mean, and this is how we represent a population mean. It's actually the same calculation. So we're adding up all the data points and we're still dividing by the total of the sample size. That doesn't change, but we use different notation to express it. So for instance, if you see a problem and they tell you that mu equals 5.0, then you know you automatically have population data here. This is a population mean. If they tell you instead that X bar equals 5.0, then you know you have sample data. So we use the correct symbol depending on if we have population or sample data, even though the calculation is the same. Don't forget that sigma here, another Greek letter, refers to sum. So this means we're adding up all the X values, so all the data points. And then that N is our sample size. And the capital N instead represents the population size. So they're both still the same idea, but we tend to use a capital N for the population and a small n for the sample. So do pay attention to the different notations as they really are important. So let's find the mean of the following set. So these are weights in pounds for a sample of adults before starting a weight loss study. And we're just going to find the mean here. So notice I have 1, 2, 3, 4, 5, 6, 7 data points. Okay. This is a sample. So the notation I'm going to use is X bar instead because I have a sample for data. And to find the mean, it's just like finding the average. So we're just going to add these all up. And then we're going to divide it by the total, which is 7 here. So I'm going to take out my calculator. I use the app on my phone. Okay. And I'm going to go ahead and add up these values. So I have 274, I have 235, 223, 268, 290, 285, and 235. And when I add those up, I get 1,810. And when I divide by 7, I get about 258.571, etc. Now, when we're rounding, my math lab will often tell you how to round. A good rule of thumb in the real world is that we use one decimal place more than the data given. So if I have whole numbers for my data, I typically would use then one decimal place instead of just whole numbers. So I'm going to follow that standard here. So I'm going to round to 1 decimal place. Now the next number is a 7, so it's going to bump that 5 up to 6. So the mean here is about 258.6 pounds. And this kind of makes sense. If I look at my data is kind of all in the mid 200s. So just make sure it looks reasonable, right? This answer seems reasonable here. So that's your mean. Now, the median of a data set is another kind of center, but it's calculated differently. So it's the value that lies directly in the middle of the data set. So to find it, the first thing we have to do actually is put the data in order from least to greatest, or I guess you could go greatest to least, but it has to be in order. And then you find the number right exactly in the middle. So if the data set has an odd number of entries, what's going to happen is you actually will have a value perfectly in the middle. But if it has an even number of entries, what's going to happen is you don't have a middle value. So you take the 2 values in the middle and you find their mean or their average. So let's do the same thing given this data here. So the first thing I need to do is put it in order. So my smallest value looks like 223. And then I have 235 and another 235. I'm just crossing them out just to help me stay organized. 268, 274, 285, and then 290. And then I find the value in the middle. Now you can just count in. If you have a longer data set, kind of what I do is I'll count in on each end one at a time. So I'll do like, okay, that's 1 on each end, 2 on each end, 3 on each end, and the number that lies right in the middle is our median. So this guy right here is our median. So here's an example where I have 7 numbers, so I have an odd number of entries, so you're going to have a perfect middle. Now, let's assume that the adult that was weighing 285 pounds decided that they don't want to actually participate. What would be the median now? So this 285 is going to go away. So I have 223, 235, 235, 268, 274, and 290. And when I start counting in towards the middle, I see that I actually don't have a perfect middle, right? If I count in again, I have nothing. So what you do is you're going to take the mean of the 2 numbers in the middle, and that's going to be your median. So I'm going to take that 235 and 268, add them together, and divide it by 2, and I have 251.5. So that's how you deal with it if you have an even number of entries. So if you don't have a perfect middle, then you just take the mean of the 2 in the middle, and that is your median. Now, the last main form of central tendency is the mode, and the mode of a data set is the data entry that occurs with the greatest frequency, i.e. the most, right? So if you have a data point that keeps occurring over and over again and it occurs the most, that would be your mode. Data sets can have 1 mode, they can have 2 modes, they can have more than 2 modes, they can have no modes, so anything could happen here. If it has 2 modes, we call this bimodal. And if it has 2 or more modes, we say it's multimodal. So if it's exactly 2, instead of saying multimodal, we'll say bimodal and be specific. Bi means 2, right? Think about a bicycle has 2 wheels, for instance. And multimodal means it has just more than 1 mode, which can happen. If there is no number that repeats more than once, then we say that there's no mode. So you don't have to have a mode. You need to have at least something repeating, a data entry point repeating to have a mode. So if I go back to that original example from the page before, I'm just going to copy down our data set here. It was 223. Now, you don't have to have it in order, but it does help to have it in order so you can see if you have any repeats more clearly. So if I go through my original data set, I do see that this 235 occurs twice, and no other number occurs twice. That's the only one that repeats. So this data point occurs with the greatest frequency. So my mode here is 235. Now, the mode is the only measure of central tendency that can be used to describe data at the nominal level of measurement. So if you have nominal level data, then you cannot find a mean, you cannot find a median. So the only thing you could do there is find the mode, so whatever the greatest frequency is. When you're working with quantitative data, we actually rarely use the mode. If it makes sense for that particular problem, then yes, it could be helpful, but more often than not, we tend to use the mean and the median as our measures of central tendency. Now, each measure of central tendency has pros and cons. So for instance, a pro of the mean is that it takes into account every data entry every entry in the data set. So when you use the mean, you actually physically use every single data point, add them all up, right? So they're all being included. However, what happens is that it could be greatly affected by outliers. So this means that one or two values that lie far away from everything else could really pull that mean and change it and affect it. So an outlier is a data entry that is far removed from other entries in the data. Again, it seems unusual and not normal compared to the other data. So not normal in the sense of, the English word normal, but normal compared to our data. Like it's very outside what our regular data is, or the rest of our data is. And we'll learn more about how to specifically figure out if values are in fact outliers in section 2.5. So for right now, we're just kind of looking at it and asking, does it seem like it's unusual? But there actually are formal techniques that we can use to say for sure if it's unusual enough, right? If it's outside of the normal realm. The median, on the other hand, is not pulled by those outliers as much. So that median can be a nice alternative if you have these outliers coming into play. It's not as affected by them. But the drawback there is it only uses one or two values, right? Because you're counting in. So you're picking either one data in the data set in the middle or you're averaging the two in the middle. So that's one of the cons there.